Dear friends, in today's class we are going to discuss about the derivation of the Snell's law. So you all know that Snell's law is sin I by sin R equals to N2 by N1. This is what we called as Snell's law. Sin I stands for angle of incidence. So this is what we called as the interface, and this is normal, and this is what we called as angle of incidence, and this angle is called as angle of incidence. And this medium is considered as a rarer medium. Let us assume it was air, and this medium is called as denser medium, which is water. Now you all know that when the light is going to be refracted from rarer medium to the denser medium, it is going to move towards the normal. That means this angle is what we called as angle of refraction. So this is called angle of incidence and this is called angle of refraction. And according to the Snell's law, sine of angle of incidence over sine of angle of refraction equals to N2 by N1, where N2, N1, just listen, N1 is the refractive index of the rarer medium and N2 is the refractive index of the denser medium. So this is the ratio of the refractive index of denser medium by refractive index of rarer medium. So this is what we called as Snell's law. Sin I by sin R equals to N2 by N1. Now we are going to derive this. Okay guys, let us say this was the interface, this medium is the rarer medium and this medium is denser medium. Here the velocity of light is v1 and here the velocity of light is v2. Just remember, whenever the light is going to travel in the rarer medium, its velocity will be more, while it is going to travel in the denser medium, its velocity will be decreased. That's why we can say v1 is greater than v2. Guys, velocity of light in rarer medium is v1, which is greater than velocity of light in denser medium, which is v2. So that's why we can say v1 is greater than v2. Now here we are going to have 2 points. One is the point A, which is in the rarer medium, and another point is B, which is in the denser medium. Now this is the path of the light in the rarer medium. This is point of interface. This is the path of the light in the denser medium. Now see, this point is assumed as O. AO is the distance travelled by the light in the rarer medium and OB is the distance travelled by the light in the denser medium. So you all know light travels more fast in the rarer medium than the denser medium, and light always chooses the shortest path for its propagation. So this is AO, the distance travelled by the light in the rarer medium. OB is the distance travelled by the light in the denser medium. Now the vertical distance between A to the interface is assumed as x. So x is the vertical distance between A and the point of interface where the refraction is going to be occurred. And this distance is what we called as y. This is assumed as y. So y is the distance between the point of interface and the B. The distance, the vertical distance between the point of interface and B is assumed as y. And the horizontal distance between A and the point of interface is assumed as z. Guys, now we are introducing three variables x, y and z. X is the vertical distance between A and the point of interface. This is O. And y is the vertical distance between the point of interface and the point B, which is in the denser medium. And z is the horizontal distance between A and the point of interface. Now we are going to assume another variable, which is d, the horizontal distance between A and B. The horizontal distance between A and B is called as d. See, the horizontal, this is A and this is B. Their distance between them is assumed as d. X, y, z and d. If this distance is d and this distance is x, then obviously this distance will become d minus z. So here you have to assume this distance as d minus z. This entire distance minus this distance will give you the distance between them. The horizontal distance between the point of interface and B is called as d minus z. Now we will apply some little bit Pythagorean theorem to this concept. This is considered as a right angle triangle where AO is called as the hypotenuse, and you all know that in a right angle triangle hypotenuse is equal to square root of side square plus side square. Now the distance AO is nothing but root over x square plus z square. Hypotenuse is equals to the square root of side square plus side square. And here this is considered as the hypotenuse OB. This distance is called as the hypotenuse, which is equals to square root of y square plus d minus z whole square. This distance is y square plus root over y square plus d minus z whole square. So AO is root over x square plus z square and OB is root over y square plus d minus z whole square. Now you all know the relation between the speed, distance and time. You know the distance better? Speed is equals to distance over time. That implies time equals to distance over speed. Now we are going to calculate the time taken by the light ray to travel from A to O. Let us assume this time as T1, and the time taken by the light ray on refraction to travel from O to B is called as T2. Now we are going to calculate the total time taken, which is T1 plus T2. So first of all we will calculate what is T1. So now we can write T1 is equal to distance travelled from A to O is AO by velocity in that medium is V1. V1 is the velocity in the radar medium. So we can write T1 is equal to AO is root over x square plus z square by V1. And T2 is the time taken from interface to the B in the denser medium. So T2 is equivalent to OB by V2, where V2 is velocity of light in the denser medium, which is lesser, which is equal to root over y square plus d minus z whole square by V2. Now you all know that we have to minimize the value of T1 plus T2 because total time from A to B is equal to T is equal to T1 plus T2. We have to calculate the total time, that is T1 plus T2. Now we have to know that this value should be minimized. Now we are going to apply some calculus to it. Now you all know that d by dz, this is respective to the z, derivative respective to the z, t1 plus t2 should be minimized, that is equals to 0. So d by dz times t1 plus t2. So we are applying derivative d by dz respective to t1 plus t2 equals to 0. Now it is d by dz, t1 is root over x square plus z square by v1 plus t2 is root over y square plus d minus z whole square by v2. So this will be applied for both of them. That's why this is derivative of root over x square plus z square by v1 with respective to the z plus derivative of y square root over y square plus d minus z whole square by v2 with respective to the z. Now equals to 0. Now this derivative respective to the z is, now v1 is considered as constant, 1 by v1 derivative root over x square plus z square with respective to the z plus here v2 is constant, 1 by v2 derivative y square plus d minus z whole square root over with respective to the z equals to 0. This is 1 by v1 derivative is z by root over x square plus z square. This is minus 1 by v2, this is d minus z by root over y square minus d minus z whole square equals to 0. Now don't be confused. Got less space here. You all know that this line is what we called as the normal. This is the normal, and this angle is what we called as angle of incidence, which is theta1, or I can say it as I. Then obviously if this angle is I, then this angle is this is what we called as angle of incidence, and this is also called as angle of incidence, alternate angles. And this angle is what we called as angle of refraction. That's why this angle is also called as angle of refraction, alternate angles. By applying the theory of trigonometry here, we can say that in this triangle sin I equals to, sin is nothing but the opposite side by the hypotenuse. Opposite side is z and hypotenuse is root over x square plus z square. From this triangle, so I am applying sin r equals to opposite side, sin r, opposite side is d minus z by hypotenuse is root over y square minus d minus z whole square. By applying those values into this equation, we can get 1 by v1 into z by root over x plus z square is what we called as sine of angle of incidence minus 1 by v2 into d minus z by root over y square minus d minus z square is what we called as sine r. This is sine r equals to 0. By transposing this, we will get sine I by v1 equals to sine r by v2. Sine I by v1, you know v1 is velocity of light in the rarer medium and v2 is velocity of light in the denser medium. And sine I is sine of angle of incidence and sine r is sine of angle of refraction. Guys, you may remember the formula, that is refractive index n equals to c by v is the formula for the refractive index. Refractive index n is velocity of light in the vacuum over velocity of light in that specified medium. So I can write it as n1 equals to c by v1 and n2 equals to c by v2. So I can say it as v1 is equivalent to c by n1 and v2 equals to c by n2. By substituting these two values here, sine I by, instead of v1 I am writing c by n1 equals to sine r by, instead of v2 we are writing c by n2. By simplifying this, we will get n1 sine I by c is equal to n2 sine r by c. By cancelling c on both sides, we get n1 sine I equals to n2 sine r. This is what we called as Snell's law. Friends, I hope you understand and don't forget to subscribe. Thank you.